Okay, so it's time to start. So welcome to this webinar. Let's see, there we go. That we call a deep dive into the 3D Bridge module. So I will be talking about the FEM-Design software today, and I will focus almost exclusively on the 3D Bridge module and try to go a bit more deeply into a lot of the features that we have. So my name is Alfred. I am a technical specialist and the product owner for this 3D Bridge software, and I am living and working in Gothenburg, Sweden. So the agenda for today will be, as I mentioned, it is focused largely on introducing all or most of the major features of the 3D Bridge module. And we will not have many slides today. I will jump straight into the software and start to show some practical examples of how you would solve different problems, how you can model different types of traffic loads. So I have these 3 examples that I will show you. The first one will be focused largely on how we create the traffic loads. I will give you a somewhat complex example and how we can build a load model from those vehicles, and then how we can apply those to our road bridge. The second example will be a pedestrian bridge example with a non-rectangular geometry, so a little more focus on handling different surfaces here. And then a third one will be another road bridge, and here I will show what I consider to be the best workflow, really, if you want to get a lot of work done in a short time using the mass generation tool. So again, with that said, things that are not on the agenda, I will not cover how we do modeling of geometry in FEM-Design. I will go very briefly into grouping, but I will not talk about combination of loads really at all. And also not a lot of focus on handling of results. We will look at some results, but just in a very simple way. And other things to know for this webinar, you can use the question alternative to ask your questions. Since I have a lot of things to cover today, I will probably just get going and continue on with my examples. So I will probably not answer any questions today, but please ask them. Please also comment if there is something that you would like to see that would be interesting for you related to bridge design in FEM-Design in the future. So please write that as well. And lastly, this will be a recorded webinar, and you all that are registered will get this recording afterwards. And this is very good because from talking to some of our users, it can be a bit difficult to get into the logic of the 3D Bridge module when you are a complete beginner. So if you feel like things are moving a bit fast during the presentation, maybe you don't get everything at once, please don't be discouraged and just try to pick up as much as you can, and then you can look through the recording afterwards at your own pace. So with that said, let's just jump straight into the first example. So here we go. And I have a bit of a list here for all of us to keep track on what we're going to do. The main focus will be on these topics, how to create vehicles and models. But the workflow will be that we first select a load surface. We go through names and results, load, lanes, some calculation options, and so on. Yeah, we will get there eventually. And to show you right away load that we will be building today. Oh, sorry. So from our Danish users, it has been requested several times to cover the special national vehicles for LM3. So I thought that this would be a fun example to show you. So this is the geometry that we're going to build, and we will in the 3D Bridge software, what you do is you go lane by lane. So we will build a vehicle for this standard köretøy A, and then we'll create another one for B, and then we will create this this distributed load, and then we will kind of puzzle those together to create a model. But let's jump straight into FEM-Design then. So we will not do anything more in the structure tab. We go into the loads tab, and then we can access the 3D Bridge module up here. So this is the traffic load module. And the traffic load module is really, this is all there is, but there are a lot of options inside of these buttons. So when you start out, you will want to use this define button. And here we have several options on what we want to define based around what type of loads we want to consider. We have an option for road vehicles and options for train vehicles. And then also depending on if we want to generate loads along a simple line model, or as in this case, we want to place our loads on a surface or a carriageway. And you have several different types that you can draw this carriageway. I will simply use this pick existing region. We have the define tool ready, and then I right click on this surface. And then I want to draw a stakeout line, which will be the line that our traffic is drawn along. So we pick one side here and then the other side, and then we press enter. And now we are into all of the options that are available to us. I will spend most time focusing on the load model. So a bit briefly here, the load case name, let's go with webinar LM3A, since we're starting with the A vehicle. The TLC we can keep for now, and these are the types of results that we want to get from our analysis. And let's keep those as they are. Down here, you have an option whether you want to have all of the simultaneous results additionally to the main results that you ask for. But to keep the time a bit down here, we will uncheck this for now. And also here, this will be relevant if you are handling different limit states. But I think for all of the examples today, that's not really relevant. So we will go with the U clone, which is kind of the fastest one. And then we jump into the load model tab. And here I want us to start to go down and select the vehicle library. And here we can see all of the different vehicles that I have available to my software right now. This probably looks a bit different for you. You have a bit fewer vehicles available probably, but the point here is that as you keep using the software, you will keep defining new vehicles, and you can expand this to your own tastes. But to create a new vehicle, you click the Add Vehicle button. And then we get to pick a name. Let's go with webinar LM3A one more time. And of course, this is a road load. And for the nominal width, right now it is set to 3 meters. And if we are using lanes that are 3 meters wide, which we will be using, if we have a nominal width that is the same width as our lanes, it means that the vehicle will not move in the transverse direction. if we have a nominal width that is smaller than the lane width, then it will be able to move in the y direction as well. But let's keep this to 3 meters right now. And now how you want to work, if we do the A vehicle here, is you want to start on one side of the vehicle and then work your way along to the other side. And you will do that by adding different objects to your vehicle model. And here we have axle loads, line loads, surface loads, and distances. And for this A1, I will be using the line load, the distance, and the axle loads. So now I'll go through this a bit quick, just so you can see how it works. We will start with a line load, then there's a 10-meter long distance, and then there is an axle load, there is another distance, another axle load, another distance, and here it's a bit unclear, but I think it's a third axle here as well. And then there's a bit longer distance, and then there's another axle, another distance, another axle, then there's this longer distance, and then there is another line load. So now let's look at those separately now. For the line load, and this will really be we will use this as a surface load. And also on a note here, personally, I'm not that accustomed to the Danish code, so I didn't manage to find exact distances and load values here. So rather than make this almost right, I will just guess some values here that will be approximately right. And then when you do the vehicle yourself, you will, of course, have to find the exact values. But for the first one here, this is the first interesting option that we have. You get to set a minimum length and a maximum length as well. And here we come into the topic of parametric vehicles. And what I mean by that is that the distributed load for the LM3 vehicle here, there is no set distance. It is simply dependent on the position of this system in the middle. So it can, in theory, be any length. And how we deal with that in 3D Bridge is that we get to set a maximum distance that can be all the way up to infinitely long. And this is what we will select here. For the minimum length, I guess 1 meter is fine. We can keep it. Here we also have the option to allow a discontinuity, which means that the software will allow for gaps within the distributed load. Right now we can keep this unchecked, I think. The number of wheels here is a bit strange maybe, but we will set this to 1 wheel that is 3 meters wide. So here we are creating one big surface load basically. And the wheel spacing will not really matter for just 1 wheel. So that's it. Then we keep going. This one is 10 meters long. This one, let's just keep it to 100 kilonewtons. Yeah, I think let's just keep all of these other options for the axle loads as the set options. This distance is quite a bit smaller. Let's use 2 meters. We keep this. This one also 2 meters. We keep this. And this one, let's see, this is maybe 12 meters long. This one we keep. This one is, let's go with 5 meters. This we keep. And now we have a distance of 10 meters. And now here we set the exact same options as for the first one. Since this one, there's no distance set, it can be really any length depending on where this middle part is set. So let's keep this 5 kilonewton per meter. We go up to infinity. We use 1 wheel, 3 meters wide. So then we click OK. Oh, okay. I've been practicing. So you need your names to be unique, of course. So now we have select or created this vehicle. So we don't have to go through this entire process again for the B vehicle. What we will do is we will right click here and we will copy to library. And then we get all of the inputs that we already did. So for the B vehicle, the only difference seems to be that here there is another axle. So I will just remove one of these axles and I will remove one 2-meter distance. And now this should be the B vehicle already completed. So now let's create this one as well, the distributed load on top here. Let's use webinar P for this. We can set this to 3 meters wide, and here we will use the surface load option. And this is what you want to use when you have a lane that is just completely filled with an area load. So now this is per square meter. So let's reduce this a bit to keep it in line with the other loads here. Vehicle names must be unique. Let's try this. No. Now it doesn't allow for the name. Oh, nothing seems to be allowed. Maybe I can, yeah, I'm not sure why this is happening, but I guess I will cheat a bit and use one of the other distributed loads that I have created in my library previously. So let's delete that one. Okay, I think I get it. This one is ruining it. Okay, there we go. So now we have created those vehicles, and now we can select those in the vehicle list here by simply clicking in one of these squares here. And we can find our new vehicles down here. So here you can see I previously did this P, but forgot to remove it. So here we will create the boundary conditions, you can say, for our calculation by putting the different vehicles into different lanes. And this is really just something for the algorithm to use later on. So I place the A vehicle with the factor 1 here. And then we place the B vehicle in the second lane. And then we place the P vehicle with a factor of 1. And here I could either choose to place it in the third lane, but what is a bit more clever to do is to use the other options. And this means that the algorithm, let's say you have a bridge project with 4 lanes instead. If you use the other option, it means that the software will place this P load in all of the lanes that are not occupied by the A or the B vehicle. So this is a bit cleaner setup. So I like to use it this way. So now we have created this load model, and what you could do, just as in the library, you can go to settings, and right up on the top, we have the save and load options. If I click the save option here, I can save this pattern into my library for really easy access later on. And again, if so here it's all of the information in the included vehicles as well as this logic. So it's a very flexible tool to use for your next projects. So yeah, but I will not save it right now. Here you can add some dynamic amplification if it's relevant for you. Let's skip that for now. And let's go into the lane alignment options. So the lanes are defined by these coordinates, and the coordinates are in y direction, and they are calculated from your stake outline's position, which in our case is in the middle of the bridge. So one way you could do it is that you type the coordinate on one side and the width, and then the software will give you the coordinate on the other side. But I will show you some nice options that we have here. So let's go with left. And then we want to use this fill option. So when I click fill here, you can see that the software can automatically fill in the geometry starting from one side of the structure, and it will see how many lanes can fit. In our example, this deck is 10 meters wide, so it can fit 3 lanes with a width of 3 meters. I think I drew my stake outline a bit tilted, so that's why these are a little weird. And then we can click new, and we want to create one on the right-hand side as well. We select right, fill, and there we go. So now we have the 2 lane geometries, and for each lane geometry, you could really define as many as you want, and then you can simply select or use this applied option for the ones that you want to include. Let's keep both of them. For calculation options, this I will go in a bit more into later on. Let's use the multi-start with 20 steps. So this is the option that will give you the most accurate results, but it also takes a bit longer to calculate. So for that purpose, or for that reason, I will reduce this a little bit. And now when I click OK, we will create a traffic load pattern. So here we can see, and we can see that it is placed right on the edge of the structure. And we can see that this is the A vehicle with 3 axles here, and then the B vehicle has 2 axles. Something that happens when you use this, which only happens when you use the define tool in the traffic load pattern, is that you get these load cases as well. Let's click on one of them to see what happens. So this is a pattern. Let's remove this for now. So this is a pattern that is used for the optimization that will happen later on. We can increase the size of our static load for you to see more easily. Let's do it like this. Okay, so if I go to the TLC1 load case, we can see that there is a load placed in the first node of this grid that was created. And if I view the load value, I can see that it's 1 kilonewton. So the system, that the way that the program works is that the analysis is not actually a finite element calculation for the traffic load optimization, What instead happens is that when you select a surface, the software will automatically create this grid, and then it will create an equal amount of unit load cases as there are nodes. And then it will generate these influence graphs from each and every one of these unit load cases. And then in the end, it will solve the optimization problem to find, the critical load position out of all of the available options. There are millions, of course, especially when we have these parametric vehicles with non-set distances. So it will look for the worst position, and then it will place the results based on the influence graphs. And then it will simply scale up the results that was calculated from this 1 kilonewton load. And we have some options to edit this grid. So you have to select one of these load cases. It doesn't matter which one. Then you right click on the pattern, and then you go to properties. And then we can see here, and this means that right now the distance between all of the nodes is 1 meters in X and 1 meter in Y direction. And here you can affect your calculation times quite a bit. So what I will do is I will increase the distance between the nodes in Y direction to double the distance. And I can, for example, increase this to 1.5 meters. And then you can see what happens. It reduces the number of cases quite a bit. This does mean that we will get a bit more inaccurate results, you could say, or we will not evaluate load positions in as many positions, you can say. But let's keep this for now, and let's go back to the load pattern we created. I want to also show you, so now we created one load. What if we want to create one load more? Then the mistake that a lot of users do is that they use the define tool once again. And the problem here is that every time you use the define tool, you will get these unit load cases. And if we're interested in the same surface, that is completely unnecessary. And we don't have to do that. Instead, we have this option that we call the wizard tool. And what the wizard tool does is it allows you to select a load pattern that you just created, and then it will copy all of the properties in that system. And then you simply go in and you change the parameters that you want to be different. So in this case, I want to create, let's say, a Eurocode load pattern, maybe let's go with webinar LM here. We can keep this the same, and then you go to the load model, and now I will select a pattern based on patterns that I previously defined. So here we can go with this one, for example. So now I get this LM1TS loads 300, 200, 100 kilonewtons placed in 3 different lanes, just to show you how it works. And we keep everything else the same. And we click create, and now we got this pattern instead. Okay, so where are we at? I think it's now time to go to the mesh, and we're going to keep it really simple. We're going to use this prepare tool, which does the meshing for us. Since I have some columns here, I will just refine the mesh a bit around the columns. That could help us a bit. Now we go to analysis, and for this, we want just the load case calculation. Now, hopefully this doesn't take too long. I had a question from Hamid. What about different load cases? Maybe that, hopefully this was an answer to your question. I will show you different ways to set up different load cases. But like I just showed you, you will create, you start by creating one load case. And then if you want to create another one, you use the wizard tool. And if you want to create a lot of load cases at once, or a lot of different results for moments and forces and reactions and so on, then you should use the mass generation tool, which I will go through in just a bit here. There we go. So let's jump into the result tab all over here. Let's look at load cases. Let's look at the shell internal forces for the MX results. Let's look at this one. One thing to note is that even though you can find these traffic loads in the load cases tab, the results for these are a envelope results. So there are really many results in each of these cases. So you select your result and you go to load, generate load cases by patterns. And what this allows you to do is that you can look at different nodes on your structure, and then you can see what the optimization algorithm found to be the worst or the most critical position for that specific result type. So you can see down here, it places the axle loads as closely as possible. And since we reversed the lane geometries, it's the same thing up here. Let's look at the LM1 results as well. And here you can see similarly, it will optimize the positions based on the node that you are currently hovering. And another function here that is nice to use is that you can click on your structure in this case, and then it will generate the load case that it is currently showing you. So this allows you to take this to a load combination, for example, where you can do a nonlinear calculation. Yeah, but that's it for the first example. Let's jump into the next one. So here we have a pedestrian bridge, which means that I will create one big lane for all of this. I will create a surface vehicle, a service vehicle, and a distributed load as well. So once again, we click the traffic load pattern. We go by define. I want a carriageway with road vehicle. I select my surface. I go from here to here. Enter. Let's go with webinar EED. For this case, yeah, we don't have any bars, so we could actually just remove this, keep the MX. Let's remove this. Let's go with uclone. So the load model for this case, we will want to, here I have already created the loads, so we don't have to go through that process again. And here I will create or select this one. And actually, let me show you what this, what's important here. It is the nominal width here. Since the geometry for this vehicle is in total, it is 1 meters wide. So by setting the nominal width to 1.5 meters, it means that the placement can be all the way out to the edges of the structure. So this is quite important. And I think the base number here is always 3 meters for you. So just be mindful of that when you're using this, this feature. We will go with this one and we place it in our only lane. No modifications. So here we just delete the second lane, and here I will just create a very large lane, simply like this, that starts at 10 meters and ends 10 meters on both sides of the stakeout line. Here, let's go with multi-start. Maybe let's reduce this a bit. So now we get this, and as you can see, the lane is much wider than it had to be. But I just wanted to show you how this affects the grid. So the grid will be it's only placed on the structure that you selected anyways. So if you have this kind of setup, you might as well make a very wide lane to make sure you get everything. Okay, so now let's create another load, a distributed load. We go to the wizard tool once again. Let's rename that to webinar surface. We can keep everything. And then we go in here and we can select this footway loading. And we keep everything else. So now we get this pattern. So what you could do now to optimize your calculation is to go into these options again. And since this is a smaller bridge, maybe you don't want the gaps to be too big. And also a note here is that if you already know that you think that one spot is important or critical to your calculation, maybe the grid doesn't end up exactly where you think the critical position is, then you would go into properties and you would decrease this distance to get the grid even denser. There is another option, and that is in the moving load button here. And here you can actually you can add loads or remove these nodes by clicking in the structure. Let's skip that for now, and let's actually go to the meshing once again. Again, we have these columns, so let's just add some more elements here. And let's just analyze these load cases. Actually, I wanted to show you first. So here in analysis, we can have load cases, or we can use this maximum of load groups option. And if you have several different traffic loads that you want to see which is the worst one, then the load groups alternative is very good. So let's take a look at that. So then you need to put these loads that we created into the same group here. So I will draw the surface one and the pedestrian load here to the traffic group. And then I will, yeah, that's it. So now we can go to analysis and we can generate load cases as well as a maximum of load groups calculation. So let's do that. So we go to the results. Let's check our shell internal forces results. We can look at this one. And once again, we go to the generate load cases by pattern options, and then we can hover the structure to see the placement. And one thing, of course, that you will see up along this edge is that it's not really optimal to have the vehicle placed like this in the X direction when we have this edge that is not parallel to that. And that we will go and change right now. But let's look at the options or the results for the surface. And then let's see how it looks in the maximum of load groups result. See if we can find something interesting. Okay, maybe the surface load was too small. Yeah, the actual load seems to be the worst all over. No. Okay, so in the middle here. Okay. But you can see that then we can see results for all of the different traffic loads that are included in that group. And this will be extremely useful if you have a lot of different traffic loads. If you're working, for example, with the Swedish vehicle models, which are quite many, and you want to see which one is worst out of all of those at the same time, then the max of load groups is a good way to do it. But let's go back to loads and see how we can better place our traffic along this edge. Then I will need to make a new load case. Yes. So we add case. Let's go with webinar pedestrian 2. So since we want to have a different surface this time, then it's not good enough to use the wizard anymore. Then we will just get the same stake outline. So here we need to define a new area, and here I will go with the polygonal option here, and I will select a surface that goes along this edge. Like this. And then I will draw my stake outline like this. Okay, so now I still want this service vehicle with a 1.5 width. Yeah, we keep this. Yeah, we keep everything else, and then we just generate this. And now you can see up here in the load case list that it starts a new TLC here. which is just this new area that you created. And here you have the here you have the same options, of course, to have a finer or a coarser mesh. But since this is correctly placed in here, let's create or do a new analysis with the new load case. So load cases and maximum of load groups. You cannot just run the maximum of load groups. You need your cases as well. Okay, so let's see. Let's look at the maximum of load group results, MX, and now hopefully we can see that this vehicle turns sideways up here. Oh, it doesn't. Yeah, maybe I made a mistake somewhere, but the general idea is to add a new surface to go along a differently tilted edge, basically. Okay, let's go to the next example. And the last one, it's not that long, but it's important because, as I said before, I think this is really the key way to use the software. So here we have a standard setup, and I want to focus on the mass generation tool. But as always, I need to start with the define option just to get this this grid and this surface selected. So we select the surface and we select from here to here. And here, one point here is that the load model that you use when you want to use mass generation, the load that you put in here at first in the define option doesn't really matter. The key for us is to generate this pattern and the lane geometry that we will use afterwards. So here I will usually name this as test. And no bar results. Let's remove this and let's look at MX results once again. So since the load model doesn't really matter, you can actually have anything added in here. So we're gonna do it like this, and here let's keep it like this for simplicity. Or actually, I can show you how to edit this. So I will make a symmetrical placement around this center line. Like this. And here, let's try and use the brute force here, see if we can have a bit faster calculation. So that happened. Let's try again. Yeah, okay, that was a bit unfortunate. So let's just run through this quickly one more time. Let's pick any load model. Let's go with this one. Okay, we can keep these for now. Here we go. What you want to is you go to the mass generation option and you pick the pattern. And now you come here, and now you have some great options. I see that I have a poor internet connection, sadly, so I hope that you can still see and hear me. But this is an important tool here. So the fastest way to generate a lot of traffic models is to go by the predefined load models. And again, I know that this looks quite a bit different for a new user, but you can build up this library as you go. And you can also contact me and I will help you personally to implement the load models that you want in the software. For this case, I want to showcase these Swedish type vehicles because there are 15 different vehicles and it would take a long time to go through the wizard option. We don't have to create every one of these, but let's go like this. And then we can select the results that we want. Let's go with MX minus and plus. Up here, it says load group name. So here you can either create a new group where all of these traffic cases will be placed. So this is good for our max of load groups functionality then. Or you can pick an existing group. Here, let's go with traffic and select the generate load patterns. So here it said that we generated 20 patterns. So this will be these two types of results. And then it seems we selected 10 different load models. So that makes 20 total. So now that we go into the load case list, we can see that we generated all of these different types of geometries. And we can also see that they are neatly grouped inside of this traffic load group. So now I guess we can go and edit this pattern also, just decrease it. Since we don't look at results in the Y direction right now, let's actually reduce this quite a bit. And let's reduce this a little bit as well. Okay, let's mesh. No columns this time, so that seems fine. And now let's generate our load cases and the maximum of load group. Or actually, I can show you just the load cases, and then we can see how long time it takes to create the maximum of load groups. So hopefully this isn't too long. There we go. So let's look at load cases. And let's look at the, let's go with the I vehicle. And once again, we want to generate load cases by patterns. And we can see, and we can also see here that since the nominal width automatically is the same as the lane width, we do not move any of these loads in the transverse direction, so only longitudinal direction. Let's look at this one. Yeah. Okay, so let's see how long it takes just to add the maximum of load groups. And I think it said something around 1 minute 15 seconds for the load cases. So you can see it is extremely fast, and it is the optimization algorithm doing a lot of work here to combine many combinations, and this is then very useful for bridge engineers, of course. So we'll look at the max of load groups, results, shell internal forces, MX, MX again. Okay, so now we go to generate our patterns again. Okay, so we can see there's a bit different. Now this, I had to make this model quite simple just to keep the calculation time down, but I think you can see the idea here that when you hover over your structure, you will see the worst result in each node, and when we are in the max of load groups, you will see the worst result out of all your traffic vehicles at the same time. So that was it I wanted to show you today. I hope that it made sense, that you learned something. And again, I know that it's quite a lot to take in at first, so please rewatch the video afterwards, and please also contact me with any questions you have about the load models or anything in 3D Bridge. Yeah, thank you for watching. Bye.